So let's talk about how to do number 12. Sorry, folks, I'm going to be talking to myself for a bit up here. First thing I would do is, nice try, Mr. Duick. I'm going to convert that to meters per second. I think it's going to be divided by 3.6, 9.72. Repeating, meters per second. All the rest of the units look good. So we want the final speed after the collision. Collision is the key word. I'm going to use conservation of momentum. I'm going to call this mass A. I'm going to call this mass B. And so before the collision, I have mass A, VA initial, plus, you know what? Car B is parked. So although I could write mass A, mass B, VB initial. VB initial is 0. This whole thing is going to vanish, so it's just going to be that. And then it says they stuck together. So the fact that they stick together, there it is, says sticks, mass A plus mass B, V final. So the final speed immediately after the collision is going to be the mass of car A, initial velocity of car A, divided by the mass of both of them. So it's going to be 1200 times 9.72, I'm going to use my answer button, divided by 1200 plus 1000. It's going to be 1200 times answer button divided by bracket 1200 plus 1000. And I get 5.3 meters per second. B wants me to find the distance. Now this is skidding to a stop. So I'm going to use kinematics. I'm going to write down D equals question mark. It does say skidding to a stop. I know VF is 0. VI is the speed right when they start to skid, which I think is that VF. I think VF after the collision is going to be the same as the speed. Let me pause for a second. So I think this 5.3 is VI. I think if I wanted to find distance, I need acceleration. Now you might be saying, Mr. Duick, couldn't you use this time right here? That's not the time to stop. That's the time the collision took. So I think I'm going to end up using D equals VF squared minus VI squared all over 2a. The question is, how can I find a? Well, they gave me a coefficient of friction, a mu. This is a job for a free body diagram. I have gravity down. I have normal force pointing up. Let's assume we're skidding to the right. Friction is what's bringing us to a stop. And in fact, what I end up with is this. Friction equals ma. Friction is mu times the normal force. That equals ma. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. That equals ma. And so if I want to get the a by itself, I'll divide by m. In fact, the m's cancel. What I really get is this. A is mu times g. And it's going to be, what's mu? I don't know what's mu with you. 0.4 times 9.8. The acceleration ends up being 3.92 meters per second squared. Now, when I plug it in over here, I am going to make it negative, because in kinematics, negative meant slowing down. So I'm going to get D equals 0 squared minus 5.3 squared all over 2 times negative, not 9.8, Mr. Duick, negative 3.92. And I get 3.58 meters. Is that what I said in my answer key? I hope I did. 3.6 meters, yep. Last thing it wants me to find is the force on one car. Now, one way for me to do this is I could go F equals what, MA, and then I can pick a car, either car A or car B, and I can find the acceleration of either car A or car B. The other way that I could do this is I could find the impulse on one car. Wow, a whole bunch of stuff just vanished. There we go, now it's back. I could use the impulse equation, and I'm going to do that. I'm going to say force times time equals mv final minus mv initial. And I'm actually going to do car B. I'll show you why in a second. The reason I picked car B is v initial before the collision was 0, so it makes the math nicer. It's going to be the mass of car B, final velocity of car B, divided by time. The mass of car B was 1,000. Its final velocity immediately after the collision, not once it's skidded to a stop, was 5.3. And the time is going to be, was it 0.15? 0.15. So it's going to be 1,000 times 5.3 divided by 0.15, and I get 35,300 newtons, or 35,000 newtons, 35 kilonewtons. I don't know why I put kilonewtons there, just to kind of refresh or remind you of the metric prefixes. By the way, it doesn't matter which car I find the force on, because forces come in pairs. Could have found the force on car A as well. If you did car A, it would look like this. The force on car A would be the mass of A velocity final minus mass of A velocity initial divided by t. The mass of car A was 1,200. Its final velocity was 5.3 minus 1,200. What was its initial velocity? They told me 9.72 all over 0.15. If I type that in, I'm going to get a negative answer. The negative is telling me that A and B, the forces were in opposite directions. But if I go 1,200 times 5.3 minus 1,200 times 9.72, close bracket, divided by 0.15, there you go. Negative 35,360. We're off a little bit on the fourth sig fig because of rounding off and such. Hope that helps.